Okay, so in the meantime, while more people join, I will get started with, I'll kick off the webinar with a little bit of introduction about what DevSecOps Live is and what we're going to do today. So DevSecOps Live at the moment as it stands is a monthly meet where we bring in interesting areas of security relating to DevSecOps. The last episode, we did a topic about how you can bring Dev and Sec together with collaborative code maps. Today is about application security. We're trying to line up good guest speakers for our next webinar as well. Webinar is being recorded as we speak. We are almost in the process of completing the previous uploads. So once that is done, this would also be available in our YouTube channel. If you follow us on LinkedIn, you would get updates there. With that, we're really glad to bring today Isabelle Mauny from Spain, who happens to be a field CTO at 42 Crunch. I saw her talk in one of the other conferences, but immediately I was very interested to host her as a guest in today's webinar. She has an amazing presentation style. I'm very sure that you're going to love it. Isabelle, if you feel the need to introduce yourself and if I fell short of your expectations and telling about yourself, so I'm going to leave that to you. So feel free to flaunt your credentials and kick off today's episode. It's all yours.
All right. Well, thank you. Thanks to you for inviting me, and I hope this will be interesting to you all. So yes, I'm Isabelle. I was just pulling up this picture just to show off, really. Just so happy I'm here. This is the first time since February 2020 that I'm getting invited to a conference. So I'm actually part of another conference, and this is where we are for this conference. It's going to be probably very difficult for anyone to guess where this is. But if you ever come to Spain, which is where I live, south of Madrid, there is a very historic town called Toledo, very famous for its iron and swords. So that's where am I. That's the city. It's one of the oldest city in Spain. So I thought I would share the view. And without further ado, I'll look at this from a more technical point of view. So yes, I am the field CTO at 42 Crunch. If you don't know us, I'm one of the co-founders actually of the company as well. And this is really an API security platform, but we're not going to talk about our platform and our product today. We're really going to look at this from a more generic perspective and in the light of the other presentation that I gave at the OWASP, which I think is where Maren saw me, or maybe at DevSecOps, I can't remember. And my goal really, I think there's a lot of work to do, is to educate people around APIs and API security. So this is really what this session is about, and I hope get away from this with additional knowledge on API security itself, but also a few tools that you can start using and equip maybe your developers or your teams with to become better at API security. Okay, so feel free to put Maren, if you can keep an eye on the Q&A. If people have questions, I'll be happy to answer them at the end. But if there is a problem that you don't understand or you don't hear well, just shout and we'll fix that. Okay, so let's start with sorry, go ahead.
Oh, you just said of course.
Okay. Okay, great. Okay, so let's start with API bridges. So if you all work in AppSec, you're probably AppSec architects, aspect specialists, and it's going to be no surprise to you that APIs are popping up everywhere around your data centers, and there seems to be no end to how many APIs the developers are actually creating. And this really, from an architecture point of view, and we're going to talk about this in a second, has really changed the way we're writing applications today. And what we're doing with APIs is pretty much giving a direct avenue into the data, which is inside our data centers, right? So it will be no surprise that for the past 18 months, about 18 months really, the number of problems around APIs has been growing up tremendously, right? So as part of 42 Crunch, we have the site called APIsecurity.io. This is a community thing. It's not a product thing. It's really about education. It's about understanding and knowing about those breaches and learning from those, learning from other people's mistakes, and we share some tools and best practices, etc. So strongly encourage you to visit, and if you feel so, subscribe to the newsletter, so we push those news to you automatically. And if you look and you browse through those newsletter, you will see a lot of breaches from very large to smaller companies. Usually the problems that surface and make up the news are the large companies that, the logos you see here on the right. Smaller companies don't really so much make it on the public and so much visible. But if we're looking at the problems that these people have had, right, we're going to see that the problems revolve basically around a few things. For the past probably 20 years, the OWASP has been telling us, hey, you have to validate data. Whatever comes your way, you have to validate what you're receiving. And that's going to really, if everybody was doing that, probably 80% of the problems will be gone, right? So this is no different in APIs. You still have to validate the data that we're receiving, and we'll talk about that. But other factors are rate limiting. So when I have an API, basically I have an endpoint I can talk to and interrogate as many times as I want, unless something stops me or slows me with rate limiting, right? And the other aspect of input validation or input is actually output. So in apps, we usually talk about the problems around accepting data and validating it. In APIs, it's actually equally critical, if not more critical, to also look at the data we're returning and what we're leaking, because again, APIs are all about give me this information and returning the information. So that information we're returning, we have to be very careful about what it is that we are returning. And obviously, because I have an endpoint I can talk to, managing authentication, authorization is very critical, right? So if we look at all those problems, that's kind of the top 5 of the issues which are actually happening. So if we're looking at why this is happening, why do we have all those problems? I've talked about 300 plus problems. Obviously, there are thousands really. They're not making the news, but we know from our customers, etc., that there are tons of problems. So the first thing is really architecture driven, which is what we used to do not so long ago, was to create applications and server side, so not client side, not on the client app. We would make a lot of control and we would be controlling very much, for example, the order in which calls would be done, the data that was returned. We would be filtering the data depending on maybe who and what was calling us. All of that was happening server side. So really what was coming out of this back to clients was rich, HTML, most likely also some JavaScript and things, but the business logic really was not on the client side. It was all on the server side. Now with APIs, we flip that around so much that we say, hey, we're going to give you all those endpoints that are going to expose some information, and you're going to consume them from your mobile apps, from your web apps, whatever application, and the work of assembling, filtering, etc. now happens or should happen on the client side. And that is the problem with APIs. Everything we do client side does not apply to whichever data we're returning straight from the API. And those APIs, they're public, they're exposed. The minute you have a web app, you have a mobile app, etc., you have a public endpoint somewhere that exposes that information. So public is really not about, I have a developer portal and as company foo, I'm advertising, those are my open API. Now, public is about having a public endpoint on the internet. And unless you're talking about having internal applications within your companies, which are not reachable from outside unless you log in through a VPN, for example, any application that is being used today will have a public endpoint. So you would have very easy access straight into those endpoints. So that's the first problem. It's really about architecture and access to those endpoints. The second thing is, you're mostly AppSec people. As AppSec people, what we used to do is say, okay, this is my data center. I'm going to build all those walls around it just to make it as hard as possible for whoever wants to come into my company and fetch that information and access my servers and my data. Make it as complicated as possible at the network level, at all kind of firewalls of any sort, application firewalls, network firewalls, etc., right? Because we had some boundaries around our data centers, and we knew how to defend those boundaries. But really, this is all exploded now. There are no more boundaries. In the world of APIs, an application can be made of things that we are developing ourselves, but most of people would be creating applications that are consuming also data which is outside of our data centers. If only, I don't know if you're using a Salesforce or a ServiceNow or any type of SaaS, and you have some information in there, you have APIs to that SaaS that have some of your data. And an application is going to go and fetch data from that outside thing that has nothing to do with you. And it will also gather information from inside, and it will go and massage all of it together. And that makes that an app. So there's no more boundaries. That's really, that concept completely exploded. It's all about data now. It's all about where is my data, what is my data, and how are we going to access and protect that data. That's very critical. It's a very change in paradigm on how we have to envision application security, right? And there's two problems that really we're not really changing there. Just like testing a few years ago. We tend to still consider security very late in the life cycle. Again, you guys are the security people. You probably have the developers coming to you say, hey, I have this application that has to be delivered in 5 days from now, or 3 days from now, or a few hours from now. Can you please have a look at it and see if everything is okay, right? And there's no way you'll be able to do correctly your job in those conditions, right? So it's always, in general, too late before we start thinking about, hey, we have to worry about security. And what makes this even worse is developers are extremely productive. They have tons of tools, tons of frameworks, tons of automation to pretty much, release an API every day if they want to. And I'm sure all of you probably have to manage not 1, 2, or 3 APIs, but more, dozens, if not hundreds, and sometimes thousands of them. And those are like popping up every day, and it's not going to stop. The new architectures, which are really fashionable right now in creating applications, are all about, having atomic, smaller services which are being assembled, and every single of the services is exposed through an API. So if anyone, here you're looking at taking what is deemed as monolithic applications and exploding them in multiple little pieces and build your application this way, every single little piece is going to be exposed through an API. So this is not going to stop. On the contrary, the numbers are going to explode in the coming years, right? So the combination of this, like the lack of tooling, the number of APIs, etc., are all very critical factors in all the problems we have with API security today, right? And all those problems and the fact that the APIs are different and the way we architect our applications is different with APIs has driven the OWASP Foundation to really focus on APIs as a separate top 10 list, right? So about 3 years ago, 4 even now, in 2017, when the new OWASP top 10 came out, there was a lot of discussions about doing an API 10, like the last of the lists, that would be watch APIs, basically. And that was abandoned because looking at all the problems around APIs, people realize APIs are like across everything in the OWASP top 10. And actually the OWASP top 10, the traditional one, was not reflecting a lot of the problems, again, around data, for example. So that's why we have a top 10 just for APIs, which has some overlap with the traditional, maybe the mostly known OWASP top 10, essentially around maybe injections and asset management and logging and monitoring. Those are common problems to any kind of application, should it be built over APIs or not. But if you look at the color coding that I have used here, the orange and the blue stuff to a certain extent, so everything from 1 to 6 is very specific to APIs. And we're going to get into a sample of that right now, okay? And along the presentation, all right? Okay, so to illustrate all of this and this OWASP top 10, here is my favorite, probably breach of the year, if not of the last 2 years, right? So Parler, so I see a lot of people maybe here from India, and maybe some other people in the US as well, I'm not sure, but Parler is you may have heard about this when there was this whole political turmoil in the US around the Capitol and everything. It is, let's say, a far right social network that has been used, for it's been said has been used to or contributed a lot to this whole Capitol attack disaster. So when that happened, basically Parler was like shut down, and right before it was shut down, a bunch of hackers decided to kind of save the data that was in there, because a lot of information was in there that was going to be lost on all the history and what had happened in there, on the organization of this overall Capitol event. And for a while it was said that they got hacked and it had been difficult, etc., etc. And actually it was not the case at all. And this is exhibiting a lot of problems in a single attack, which is quite representative. So the first thing is, well, there's an API and it's open. So anything that allows you to access public data, so any of the public posts on that social network, was directly accessible with absolutely no authentication, just direct endpoint, you talk to it, it answers to you. No API key, nothing, right? So that's the first problem, obviously, which is broken authentication. So that's API 2, right? There's no rate limiting either. And so I can call as many times as I want. And another thing, which is, as you can see, the number 1, API 1 is something you probably have heard before as IDOR. In this OWASP top 10, it's been renamed as BOLA, Broken Object Level Access. And this is what this is about. It's if I'm trying to get access to a post on Parler, let's say, and that post as ID 123, right? And I'm trying then to access another post that has ID 456. Something somewhere should look at whether Isabelle has access to 123 and 456, or only to 123. So it's really about making sure that whichever resource is being accessed through the API, the actual piece of data, it can be, think of this as a bank account or a user profile, whatever it is, right, is identified by something, and that something, which is an ID, if that ID is sequential, so I can iterate over it, you can etc., etc. So you don't have to be very smart to see that it's very easy, and just increment by 1 and see how many we can actually get through this way. Okay. Can you still hear me okay?
There was a little bit of a glitch, but it's all right now.
Okay, because there was a little message here telling me something went unstable.
Isabelle, do you mind if I turn your video off momentarily to see?
Sure. Absolutely. I'll do that. So hopefully that will be better now. So sequential IDs. So as you can imagine, if I can write a little engine that goes 1 to 3, 1 to 4, etc., and there is no authentication and there is no rate limiting, I call this a recipe for disaster, right? So that's how 70 terabytes of data has been extracted in about 2 days, right? So that's the first main problem, is somebody has been able to kind of write a loop and get all the data that was public on this site, okay? Now, the data that has been leaked, also, we have a problem there, which is like it has all the raw information about the data. So there's a lot of pictures and videos, etc. And when you have pictures and videos, you have this metadata attached to it. That says a lot. And for example, GPS coordinates. So in those videos, there were GPS coordinates of people shooting it, so you know exactly where they are, basically. So that's very sensitive data being leaked. And finally, as I said, considering the potential role that this platform has played in this whole capital thing, a lot of people scramble to delete their post and any trace of what they have been saying or posting around that event, right? Now, very big mistake here on Parler's side was that what they did was, rather than deleting actually the data whenever somebody was asking to delete the data, they just actually turn a flag on to say this data is deleted, but the data is still there in the database, right? And what they would do is at the UI level, so back to what I just said before about architecture and how to filter out the data. On the UI, they would just look and say, if flag is on, then don't show the post. But the post and the data was still there in the database and was never removed. So that's, extremely bad practice. And, last and not least, all of this went absolutely unnoticed, right? So really, nobody saw there was probably a massive number of calls on that API, and it should have been shut down. I'm sorry, but nobody saw anything, right? So probably no logging, no monitoring of any sort was happening on the system. So that whole thing, 70 terabytes of data in 2 days, like it's a nonstop thing. Basically, they started the thing and it ran nonstop for 2 days and nobody has seen anything, okay? So you could think this is a very extreme example. It is, in a sense, but it exhibits something which is not actually extreme, which is actually very common, which is we have a top 10, and in most of the large, if not all of the most large breaches or I would say worst vulnerabilities, it's never one thing which is wrong on this top 10. It's always multiple ones. Every single, what happened to the Facebook, to the Uber, to the T-Mobile, et cetera, it's always a combination of things that made it noticed and stopped and seen, et cetera. So it's very important for what I'm going to say now about how to approach this kind of issues. Okay. All right. So going further now, we'll talk about this later. How can we address this stuff, right? And that's really what I want to talk about. So action plan. Well, the first thing is, this is a DevSecOps group, so I really hope that I don't have to convince any of you that we have to embed security into the development lifecycle. But that's really, the key thing. For me, this is, very much what we have to do is just think about, for APIs, about the design time decisions. And as security practitioners, we really have a role to play in helping development doing this. So we'll talk about that in a second, how we can really put security in the life cycle into automation. We'll talk about that a bit. And really, as a general principle, hacking ourselves and see how we can actually do that. What are the tools we have to actually do that? Okay. So first of all, design decisions. You know this, but it's critical. Bad design decisions are extremely hard to undo, right? So this is an extreme example here again. But I see this with my customers all the time, which is that they discover very late in the life cycle that some decision have been taken on how an API was going to be secured, implemented, designed, etc. And there's little they can do after the fact. And in some cases, it is as extreme that the entire API actually has to be rewritten, which, as we know, is very often extremely hard to do because everything we have to do is always for yesterday, not for tomorrow, right? So we really have to, if there is one key message as a security practitioner, we really have to go and talk to the architects and to the developers is, okay, let me help you. Let's work together on how we can really look at security and help you understand the implications of some of the decisions that you are going to make as you start writing your APIs, right? And the first one, this is security, so it's all about risk. So what is the risk? And obviously, you're not going to secure the same way, even implement the same way, an API that transports very sensitive information. If any of you here is in, I don't know, in the banking industry or in the finance industry, healthcare, any of the industries that transport and manipulate potentially very sensitive data, the security rules and constraints that you have and the risks that you have are much higher and stringent than people implementing the next generation of the weather data, right? For example. But you need to know that. So whenever an API is being created, we have to think about this. So what is the data that we're going to expose? How sensitive it is? Who is going to consume that data? And there is a typical problem that happens in companies today, that an API starts as a little thing in a corner that only we are going to consume, and it's only for internal consumption. So the risk is lower. It's not like it doesn't exist, but the risk is lower. And then that API is really cool, so people like it, and we decide to open it to a wider audience and now to an external audience, and then maybe it becomes completely public. And as we go through that journey, the risk is much higher as we expose this to more and more people and to more, less controlled environments, right? So this is really important. That's the first thing we need to look at. And then, what is this data? Is this data, if you take the open banking world, I'll give you two examples from the banking world, which are easy to understand for anyone, which is in open banking, you have an API, for example, to find the ATMs around where I live, right? So very, I would say, pretty public data can be accessible to anyone. I actually know a bunch of banks that expose this information with actually zero authentication, right? Makes sense. So, okay, that's one API. And on the other end of the spectrum, in open banking, you would have a payment API that allows you to transfer, money across bank accounts, right? So A, the bank account data and all its information is sensitive. B, the amount of data we're transferring, obviously, if somebody catches this in the middle and replaces 100 by 1000, that's a problem, right? So we probably need to sign that data just to make sure this cannot happen, so that we cannot also change the account number, either the origin one or the target one. So that's all these questions that we have to ask ourselves before we even start talking about any type of code, okay? So that's the first thing. Interface design. So again, what is it that we're going to allow people to do through that API? And who are those people? Are there internal administrators? They're just normal developers within the company. This is like the mobile app of the company, or this is like an open API, open in the sense of something we want to expose to the outside world so they can come and integrate with our company with no specific agreement of any sort. So again, who has access and how they're going to access, and how are we going to control the access to those different operations and APIs, right? This is where we have to think about those resource IDs. Again, I find this at every customer right now. We have that problem that people have been designing their APIs and use those pretty much, like you have a database and you have an incremental counter. So this is client 1, client 2, client 3, client 5, etc. And that's the ID we use for the resource, even as part of the API. We really shouldn't do that. We should mask that information and never expose it back all the way to a client. It should really be something that stays inside, and to the outside world would find a way to show this resource and index that resource with something that people cannot guess. Maybe we have to design the API differently so we don't even expose that ID at all. Again, this is something we need to think about, because I can assure you that this is something that you will not be able to change once the design is actually done, okay? And also define the data. That's also very critical, right? The structure of the data that we're going to manipulate, because this is where all the attacks based on the data are actually, And finally, admin operations. So this is also, we tend to mix in the same system the actual admin operations for the data and the operations that users are going to use, right? So we really have to make sure we design this properly as well. And finally, how are we going to operate all of this? So again, logging monitoring, this is very critical for AppSec and security in general, everything related to forensics, right? When someone gets into your system and starts playing with your APIs, do you have a place where you can go and see this activity centralized? Are you able to trace how a call came into your data center end to end? Identify who called you, have some alerts if something pops up. None of this will happen if at design time you have not planned properly for monitoring and logging. Because again, that's another thing which is very difficult to add on top of the code, after the fact. So same thing for rate limiting. That needs to be designed. You don't rate limit again my get ATMs to, that's probably something that's used thousands of times a day by people through my banking app, versus doing transfer of money between account A and B. You want to probably rate limit that one much more than the other one. Again, that needs to be designed. It's part of the interface design. And manage versions. So APIs are not written in stone. They change all the time. We have new versions. How is that going to happen? What happens when version 2 comes and version 1 disappears? And for example, there are problems around leaving version 1 running right there in a corner. We forget about it, but it's still there and it has access to production data. We won't even test it anymore, and we tend to forget it. That really should not happen. Must not happen. We need the proper governance around the API, so we actually know what is deployed at any point in time, what is in production, what is being retired, and we can make sure through testing that this version 1 is actually not there anymore. We have to keep the testing for version 1 running, but that test now it needs to fail because that endpoint is gone, right? For example, that's one way of doing it. Okay, so that all that design is very critical, right? So one of the things that I think is very critical for the AppSec people and the developers and the ops is to have a common language, right? Again, we very much believe in my company, and this is a personal belief as well, is that if we don't collaborate, therefore DevSecOps, right? This is all about collaboration. If we don't collaborate between all the constituencies of creating APIs, we're not going to be successful at making sure that our APIs are not so susceptible to vulnerabilities, right? There's a big trend right now in the API security market to kind of catch problems after the fact. So like put some magic, AI somewhere and it will have a look and find all the problems. So yeah, some problems will be found, but really that cannot be the end game. The end game really needs to be that we become smarter, actually catching, making sure that we're not introducing those problems to start with, right? So we really need to think about the same way we do infrastructure as code to do security as code. And at 42 Crunch, we do this based on the definition of the API, which is called Open API, as the slide I had earlier. But as a more general principle, it's really all about describing statically, this is what my API, that's what it does, this is the data it transports. Those are the actual things that I want to make sure are always there when for my APIs. This is the type of security I want. It needs to be whatever. an access token in the form of a JSON web token, or it has to be OAuth, or it has to be OpenID Connect, whatever it is that you want to do. That's really depending on your company and what their regulations and compliance and what your rules are. But the key thing is you need to have this described in the way that you can track, well, this is the API, that's what it does. Yep, it has the correct configuration. We can version this, we can diff it, we can see who has made some changes, and that's going to enable you to take what I call, what's called in a positive security model. And what that means is instead of taking this approach whereby we're focused on threats and how to describe threats and maintain a list of signatures and threats descriptions, etc., maybe massive regular expressions, whatever it is, we're going to focus ourselves on describing what we want to allow to come in, right? So everything is blocked by default, but we have those things that we know will come our way, and those are API calls. And if those API calls are not there, then we will not, if those calls that come are not part of the description that we have created, then we want to reject them. I think this is pretty much a sacred grail in the world of security, being able to describe what we want as opposed to describe what we don't want, right? In the API world, it is possible, thanks to this open API description, we can actually do that. And there is open API, there's async API, there are standards which allow us to really describe what an API does, right? And that is going to give us that security as code and this positive security model. So as you said that, so define the expected and reject everything else, define everything that you want. So in open API, it would be the same thing in async API. That's where I can describe my security, all my data formats. We're now enriching this also with SLAs for rate limiting, with security, advanced security workflows. So the idea is really to describe very thoroughly all the exchanges which are being done through the open API definition. And your developers use this today already to do all kinds of things, to do mockups, to do testing, like normal testing, functional testing, right? To do documentation. There's a lot of things that they can do. And now this open API, that's why I'm talking to you about this, is because this is the kind of universal language being spoken by all the developers of the world when they have to describe their APIs. There's a lot of security tools that are starting to, take this on board as a way to be configured. Like you may have web application firewalls, the F5s, the Imperavas, maybe Akamai, all of these companies, very traditional web application firewalls, have started to support open API, so you can import an open API definition and predefine all the path and the verbs and everything that your WAF needs to go through, and everything else is going to be rejected. So that's one example. But there's also, in the spirit of DevSecOps, a lot of tools you can use to actually test and manage this hacking, this auto hacking, and this automation for APIs. So there's a few of them here. I'm going to show you this audit that we have in 42Crunch, but let me discuss a few of the others as well. So the first one you may know is ZAP, right? So I'm sure you've all heard about OWASP ZAP, which is like a fuzzing tool, so you can do automated fuzzing and testing of your applications through ZAP. So ZAP is an open API extension that you can install. And what this will do is it will, rather than having the system use the spider and the crawler to go and discover what are the paths that can be fuzzing, then it will be auto-configured to have all the at doing that fuzzing, right? So if you know ZAP, this is like the ZAP as usual, but it's smarter in terms of having a pre-configured set of path and information it can use to do its job, right? StackHawk, I'm sure is like a commercial version of WASDAP that also have the support for Open API. If you don't know it, Microsoft Wrestler is also a very interesting tool that would also consume Open API and allow you to do testing of your APIs also automatically. All of these you can put inside your CI/CD pipeline so that this testing every time a new API is being promoted and and deployed, you can automatically run ZAP testing or Stack Overflow testing or Wrestler testing, whichever is better for you. And do this every time there is a new change, right? So that you don't manually have to do all this fuzzing and testing. You can directly consume what the developers give you, which is this open API file to actually do that, okay? One project for me, which is super interesting, so as I said, I'm here in Spain, is BBVA is a very large bank here in Spain. And they have this tool called API Check. And API Check will allow you to do job testing, among other things. So actually, let me show that to you because I opened this in there previously. I thought I had. Here it is, okay. This one is really interesting. So it's completely open source. It's called the DevSecOps toolsets for REST APIs, right? And it's the goal really is to build a pipeline of tests that you can do. It's mostly Python based, and you will be able to chain a number of tests on your APIs inside your pipeline. And then this pipeline you can call from a WhatsApp I just talked to you about, or it can be Burp if you're using that in terms of testing. And it has that's two very interesting things. One is to test this open API definition, so you can lint it and check it to make sure it's valid before you actually use it. But the most interesting part of this is really testing JWTs. Why is this important? So let me show you a JOT, right? Let me show you a JWT, and that I have. Let me just create one here for one of my APIs that returns some JWT. So this is what a JWT looks like. Let me just go in here, copy and paste this thing. There we go. All right, okay. So this is a JWT. So when you look at this way, it doesn't look very nice, but this is base 64 encoded data. It has a header, which is this red piece here. It has payload, and this is a signature. In general, JSON Web Tokens are signed just to ensure that the payload that you have inside cannot actually be changed, okay? But if I look at in the clear, so again, this is base 64 encoded and is not encrypted. So it's just, you do base 64 decode and you have the clear information, right? This is often neglected as a way to evade data when I return a JWT, like I just did now, or to accept data in. There's a bunch of attacks that are based on JWTs today. And it could be injections. This is really a JSON structure. It's a structure by which I'm transporting data. So it's actually completely part of my interface, of the data I'm manipulating with my APIs. So we tend to look at the data the API returns or accepts through an API call, and not so often look at the JOT themselves and what they should have inside. So the great interest of that JWT checker is really to allow you to actually check, what is the algorithm that is being used here? Is it the one I'm actually expecting? What are the claims that, like the properties which are being transported? As someone tried to inject some data in here, I should not be accepting in. On the contrary, is someone trying to evade some information through a JWT I should not be evading, which in this case is pretty obvious because I even have passwords in the clear in that thing. So this is a very bad API that has plenty of problems, one of them being to leaking passwords. But in real life, this is an extremely useful tool. And I think it's the only tool that I really know that allows you to do this type of testing automatically. And again, this API check tool is a framework. So you can create your own checks to add into there. You can include it into additional auto checks. It can, for example, detect some sensitive data. So you can define what sensitive data is. It could be IPs, it could be, you define whatever you think is sensitive within your company. And again, you put that into your CI/CD pipeline and it will find those problems automatically. So a very interesting tool that's being enhanced right now by those guys at BBVA. But you can really use as a backbone of additional testing that you may want to do also as part of your DevSecOps pipelines. Okay. So that's our friends from BBVA. Okay. And also you want to have a look at this Fuzzlighter project. So this one is specific for IDOR. As I said, the API one, like the top one problem in APIs today, is being able to basically scrap data by iterating over sequential IDs through an API, right? So this framework here is going to help you test again automatically this type of problems. So you can describe the information that you want to test, right? So it's really a DAST framework. That's a nice thing to add to your DAST testing and maybe code analysis. And it will do all this testing again automatically, very lightweight, very easy to do. So that's something you can very easily add again to the CI/CD pipeline and automatically do this testing. So have a look at it. It's very easy to install and play and test. And I would highly encourage you to have a look at that and test it. And while I'm here in demo mode, I'm just going to open my Visual Studio Code so I can show you what we do, which is this audit. So when I have open API files like those ones, what does that do? What does an open API file do if you don't know about that? As I said, it basically describes all the path and all the information, all the path and all the information that the API is going to accept inbound and respond outbound, right? So I can be extremely precise about describing this information in my open API file. So as a security practitioner, you will know that, hey, this API accepts a header, which is called X access token, and it's the string. And by the way, this is the pattern for it. So you could do some testing, automatic fuzzing, for example, to try to inject an integer instead, or try to inject a string that does not match that data and see what happens, or a very large X access token and see what's going on, right? So you have all that information ready for you to use here on what is the data for the data that API is actually accepting inbound and outbound. Now, what we're doing on top of that is we're going to use this really as, it's not going to be able to connect to the backend. We're going to use that as a test tool for, sorry, I don't know what. Okay, excuse me. The audit, what it's going to do is analyze that open API file. So let me do this from a different place here. So you have this tool online here at apisecurity.io.tools.audit. Okay, so I can just go and browse a file in there. So I'll just take the same file I was looking at right now, which is this one. Okay, and open. All right, so this is going to send that file to our platform, and it's going to return a report, okay? And what this report is going to look at is what is the security aspect of this API, like how is it secured? In this case, this is secured through API keys, okay? And more importantly, about data. So how well is the data defined? Is it constrained and bound? As we said, APIs, data, it's all about constraining and validating. So we are going to help the developers through the tool find out all the potential problems around the data formats and around the descriptions of their API very early in the life cycle again, because that's something that they will be able to do the minute they have defined the interface of their APIs. So you can use this online here. That's completely free if you want to import some of the APIs developers give you. If you're a developer, go and check that. You should be able to do it from Visual Studio Code, I guess, because I'm in the hotel here. I have a certificate issued because I'm probably presenting a different certificate. It was working before. That's interesting. And that's why it's not working from here. But you have the same functionality in Visual Studio Code, in IntelliJ, in your IDEs. And of course, you have the same functionality in CI/CD again, because what I want to be able to do is whatever finding this tool has, I want to be able to capture that again as early as possible and decide whether this is acceptable or not. So in this case, for example, this API is using an API key, right? Is that acceptable? Like as we were saying before, from a security compliance point of view, is that acceptable? Is this API within my company should be using OAuth instead, or maybe OpenID Connect, or whichever way has been decided at the corporate level. So because we're going to tag all those problems, you'll be able to, like much like in any static analysis or dynamic analysis tool, then filter on the problems which are being reported, and very early go back to development and say, hey, no, sorry, can't do. You really can't use an API key for that specific API, or now you go in production, whatever it is, because here, we mandate that you have to use OAuth and nothing more, right? So this audit gives you this very detailed report on what is the problem, why is it a problem, how to fix it. It has about 300 tests that you can actually do, that we were doing here, and we would report on. So I encourage you, have a look, try it online first, and if you want to then use it from CI/CD, you'll have to onboard our platform, but it's very easy to do, and you can see how it would integrate inside your CI/CD pipeline together with the other tools that I mentioned. Okay, and this really concludes the presentation. Again, the salvation here is really to start looking at security from design time. Any problem we fix early, very easy to fix, maybe, because it's not a design issue. The further down the line, the more expensive it's going to be, right? And this hack yourself, so all those tools that I mentioned, that fuzz, that test the GWTs, that send you some bad information, etc. All of that, again, needs to be automated. So the developers, they tend to automate the functional testing, but really have to also automate through that single, and that's the great advantage of that OpenAPI file, is once you have that file, you can do all that negative testing yourself as part of AppSec. If you're a developer on the call here, you can do this as a developer as well. The more, the merrier. So if you actually take those tools and do this testing, that's all tests that hackers will, they will not be the ones discovering all those problems and telling you, right? And take those and automate those, put them into your security pipelines, so that, again, all of this is being reported and visible as early as possible and as easily as possible. And that's for me the only way all of this is actually going to scale, right? And so if you have more than 20 APIs, manual testing and everything is just not going to work for you guys. All right. And this is pretty much what I wanted to say. Sorry, I took a bit more time here, but I'm open to any questions and comments you guys might have.
Thank you very much, Isabelle. Towards the very end, I wish this presentation never ended, because the tools kept on coming and coming and coming. And a request to the audience, if there's any questions, feel free to put them in the chat, or use the Q&A section, put your questions there as well. So there's a few. Is API security.io audit free? And is there a free on-prem version of API security.io? Because some companies are still terrified about the cloud and software as a service in general.
Okay, so the first question is just The other one is no, right now we do not have an offline version of this. The code is actually on our SaaS, right? Now, we really do not do anything. If you're using API Security.io, you're using any of the IDEs that I mentioned. We don't do anything with the data. It is really stateless. We just receive the OpenAPI file, we audit it, and generate the report, and we return you the report, and then we totally forget about it, right? If you're a customer and you onboard the platform and use it from the platform, then we will keep that OpenAPI file and that report. But if you use it from API Security.io, from the IDEs, we actually don't keep anything.
All right, thanks, Isabelle. I hope that answers the question. And the other one, fuzzing tools, the list of fuzzing tools normally requires someone to look at the input for the fuzz and then analyze the output or the response of the fuzz, correct? In order to determine whether a vulnerability is present or not. But you shared some interesting ideas about automated fuzzing.
Yeah.
So just wondering, how do these fuzzing tools detect vulnerabilities automatically?
That's the great advantage of using this OpenAPI definition. Because in an OpenAPI definition, you would have the data and the format of the data, which is acceptable in, but you will also have the format of the data, which is acceptable as out as response, right? This is very precisely defined. And one of the things that the audit is actually, driving people's attention to is whether they're missing maybe some response types. If they have some response types that are defined with no data attached, we'll tell them that too. And all of these are kind of critical errors that they have to fix. So that's how the fuzzing tool knows. It knows because the OpenAPI tells it. So there's no magic here. It's because the OpenAPI describes all this data automatically. And we do the same in our scan tool, where we validate and look at the exchanges of data. We will typically, for example, we will send a wrong content type. And how do we know it's a wrong content type? It's because in the file, it tells us, this API is expecting application JSON, right? So we'll know this is the right one to send. So we'll just go and send application XML or send gzip or whatever it is and see how the API is reacting. And what it should happen is you should get a certain response like 415 saying, nope, sorry, wrong content type, with a payload attached to it that has also predefined on what is the format of the error message that comes back. So it knows. That's how, and that's the beauty of it, is it can automatically validate the responses against what the contract says.
All right, thank you. And here's a basic question. What is the difference between OpenAPI and Swagger? Are they related in any way?
Yes. So Swagger is the old name. So what happened is Swagger is the original project. And version 2.0 was donated to the Linux Foundation. And as part of the donation to the Linux Foundation, it was renamed as OpenAPI. So OpenAPI version 2, Swagger version 2 is the same. And then OpenAPI is just a new name. So yeah, it's functionally absolutely equivalent.
All right, here's a question from me. You mentioned a lot about JOT tokens, and normally JOT tokens are sent as bearer tokens as part of HTTP requests. I'm just thinking, hey, we have API keys to access our APIs. Isn't that sufficient enough? Why do we need these bearer tokens or HTTP headers? Because you sign up for as a Twitter developer, they provide you API keys. So it is kind of secure just to use the API keys, right? Why do we need this additional bearer tokens? What's the role of these things?
It's an interesting question, and it's a kind of question we have to ask ourselves when we do design and we make a choice. So the big difference between an API key and typically what's called an access token, and which way you obtain that token, is really how long it is valid for and what it gives you access to. So an API key typically is like a bit string, right? And when you get one, it will be valid for maybe months to come. And one of the big plague that we have right now on API security is we have API keys hard-coded in code, in applications, and are leaked all over GitHub. There was a recent analysis of GitHub of token scanning, and they found 300,000 API keys hard-coded within GitHub repositories. So that's the first plague around API keys. Now, if this is something you can live with, again, it depends the risk and what your API is doing, that's okay. But in many cases, what you want is a solution whereby you obtain dynamically a token based on other information. That token is available and valid for a limited amount of time. It could be actually, normally it should be minutes, like maybe 15 minutes, 20 minutes. Why? Because if this gets stolen or whatever, then the scope of the bad that can be done with it is very narrow, because in 15 minutes from now, that token will not be valid and will be rejected, right? And the other thing is, to tokens and the auth mechanism, etc., you have this notion of scopes, which treats the authorization aspect of things in terms of, okay, if I have that token, when I obtain that token, I obtain that token to be able to do a certain number of things. So there is a scope of what I can do with a token attached to that token. So I'm being delivered a token to be able to do get account details. But if I'm trying to do post account details, I don't have the credentials to actually to do that. And that API will not be accessible even if I have this valid token, right? So there's much more richness in first of all, in the scope of what you can do, and second, in how can this system be abused if that token was to be lost. But again, the choice between the two, there are pros and cons. On what there's still people using basic authentication, right? I recently talked to somebody who is using basic authentication across all their APIs with the same user ID and password for all of them. So one token gives you access. I won't tell you who those people are, obviously. One token gives you access to absolutely entire set of APIs that they have. And obviously this is basic authentication. So I just, listen a bit to the traffic, get the authorization header, and I have a user ID and a password in the clear, right? They know that's not the right thing to do, but for now it works for them. So again, it's really a question of evaluating the risk and what are the pros and cons of each of the options that you have. And if you want, this can be another session with you guys on the pros and cons and how it works, and should I use JWTs or not, and how do I use JWTs. Is like a full hour just to do only on that part. Sorry, that was a long answer, but
no, that's great. We'll be very glad to host you in the future, and hopefully some of the improvements that you're going to be doing in the field of your work. So I want to thank you for your time today. Don't want to hold you any longer because you're our special guest, but here's a few areas or highlights that I've enjoyed in today's talk. Part of the story is great, particularly 6 of the top 10 API security risks are covered on that part of the story. And the things about, everything had to be done yesterday, that's something that we hear very often working with customers. And the other story about internal APIs, it's just an internal project, and all of a sudden it's going to be public. When you ask where's security, they're often going to tell you security is coming up on the next sprint or in the next 2 sprints. So this is great. I hope everybody has their favorite highlights as well. And I want to thank you very much for being our special guest today and taking your time to present and staying true to the agenda, the tools and tactics of rescuing you from API security mistakes indeed. And for every other participant that has joined us today, this is being recorded as we speak. It's going to be up in our YouTube. If you follow us on LinkedIn, you're going to find the link there. And you will also find links about what our next episode is going to be. So thank you very much, everybody, for tuning in today and making your presence felt in the webinar. Isabelle, we have our gratitude to you as well. Have a good evening and good day, everybody.
You take care. Thanks.
Thank you.
Take care.